Okay, in this video we're going to look at some real-life problems that utilize the skills that we've learned so far in this section and show how those skills and that math can help us to analyze different real-world or real-life situations. So in this problem, the Student Council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain. So this is the first thing that we want to look at. And how are we going to know if a table of values can be modeled by a linear equation? What we're looking for is that the slope between any pair of points is the same. So we're going to look at the change in x. We can see we're going up by 2 in each of these, and the change in y would be going up by 12 in each of these examples here, and for each of these pairs of points, or for each of these coordinates. Now you recall that what slope really is the change in y between two y coordinates, between 2 points, over the change in x between 2 points. So we can see here that the change in y between each two pair of consecutive points is 12. The change in x is 2, so that means that our slope is 6. And just as I've done in previous problems, what I'm going to do next is use that slope and one of the points to write a linear equation in point-slope form. Now, I don't think that I explained precisely how we know that this situation can be modeled by a linear equation. So let me answer yes. So yes, it can be modeled by a linear equation because the slope between any pair of points, or perhaps that should better be stated, the slope between every pair of points is the same. So that can be boiled down to just saying that the slope between every pair of points is the same. So that's how we know that we are working with data that can be modeled by a linear equation, because the slope between every pair of points is the same. If the slope between any one pair of points was not the same as the slope between any other pair of points, then all we need to do is show that the slope between two pairs of points is not the same, and we would know that the data could not be modeled by a linear equation. So we'll come back to our example here, and we're going to use one of the points. So we'll just use the first one, y minus the first y value is 34 is equal to the slope, which we found to be 6, times x minus the first x value, which was 4. So that's the point slope form. We're next going to multiply out to distribute. We get 6x minus 24 and y minus 34 on the right. When I add 34 to both sides, I end up with y is equal to 6x plus 10, and that is the final linear model. So if possible, the last sentence reads, if possible, write a linear model that represents the cost as a function of the number of foam hands. So here, y is the cost, and x is the number of foam hands purchased. So let's take a look at what this equation means. What the equation means, or says to us, is that 6, the slope, represents the cost for each foam hand. So we're going to multiply the number of foam hands that we want to buy times 6. The 10 represents an initial one-time fee that may be for processing or shipping or something of that nature. Alright, so we're going to go on to the second example of this sort. And this problem says that you pay an installation fee and a monthly fee for internet service. The table shows the total cost for different numbers of months. Can the situation be modeled by a linear equation? Explain. So once again, how will we know that this situation can be modeled by a linear equation? We're going to take a look at our differences. They happen to be going up by 3 for each pair of data that we have, and the y values, or the total cost, is going up by 126. So because we have the same consistent change in y when we have a consistent change in x, or in other words, the slope between every two pair of points is the same, then we know this can be modeled by a linear equation. Now the next thing we want to do then is, if possible, and it should be possible since we know that the data can be modeled by a linear equation, is to write that linear model that represents the total cost as a function of the number of months. So our x value is going to represent the number of months, and y is going to represent the total cost. So what we do first, we use our point slope form and substitute the slope that we have in any one of the points. We'll just use the first point. So we have y, the first y value is 176, is equal to, now we haven't talked about the slope here. The slope is not 126, the slope is the change in y. So m is equal to y2 minus y1 over x2 minus x1. So in this case, we know that between the first and second points, the change in y is 126, the change in x is 3, and so the slope is 42. So we're going to come back here and use that slope, 42 times x minus x1, which would be 3. Now we're going to distribute out 42x minus, this would be 126, is equal to y minus 176. We'll add 10 on both sides. Y is equal to 42x plus 50. And so this would be our linear model that models the situation that we see, which is you pay an installation fee and a monthly fee for internet service. So 42 here, 42 is the slope, and it represents the monthly fee. So we're going to pay 42 times x, the number of months that we're going to use the internet service. The plus 50, on the other hand, is the y-intercept. And here it represents the one-time installation fee. And so we've written our linear model, we've interpreted the slope and the y-intercept in the context of this problem. The 42, or the slope, represents the cost per month. The 50, or the y-intercept, represents the one-time initial installation fee. And so that's going to do it for these real-world problems, and in the next videos we will get on to the homework problems.